Bismillahirrahmanirrahim. Assalamu alaikum dear students. I'm Arif and I welcome you all in today's session. To access the notebook for today's session, you can access my course page on my personal website arifbhat.me. The other way is to download all the notebook files from course GitHub account arifpucat, and all the notebooks for this course are housed in this public data science repository. Well, this is a Jupyter Notebook dashboard running locally on my machine at port 8888. And here is the notebook for lecture number 6.9 of the 6th module, overview of machine learning, for the course titled Tools and Techniques for Data Science. Well, this is the third video on data pre-processing. And in the previous two sessions, we have discussed and practically understood different techniques of detecting and handling outliers and missing values imputation. And today we will discuss different techniques of encoding categorical features. So let's move ahead and see the agenda for today's session. As usual, we will start with a quick recap of data pre-processing and feature engineering. Then we will discuss categorical or qualitative data type, having two subcategories, nominal and ordinal. After that, I will give you a bird's eye view of three questions. What do we mean by encoding of categorical data? Why it is required and how to do it? We will practically understand sklearn label and ordinal encoders for transforming ordinal variables, and we will use Panda's get dummies and sklearn's One Hot Encoder for transforming nominal variables. After doing a step-by-step hello world on all these, I will do a train test split on a dataset and then do the transformations. And remember, this is a recommended way that we should use train test split and then do all the transformation to avoid any data leakage. And finally, at the end, I will show you how the ColumnTransformer makes our life easy by applying different transformations to our dataset in a single line of code. So there is a lot to learn today. Let's start playing. And let me once again start with a quick overview of data pre-processing and feature engineering. As said before, many times, data pre-processing is the process of making your data ready to be fed to a machine learning model, while feature engineering is the process of using domain knowledge to extract features from raw data using data mining techniques. These are the 6 tasks that we normally perform in this phase, and today we will discuss and practically understand different techniques of encoding categorical features. Okay. Well, my dear students, before we discuss different techniques to encode categorical data, let us have a quick recap of data types that we come across in our data sets most of the time. The two main categories are numeric or quantitative and categorical or qualitative. Well, this numerical data is a type of data that expresses information in the form of numbers, while this categorical data is a type of data that is used to group information with similar characteristics. This numeric data is further classified into two types. One is continuous and the other is discrete. This continuous data has values that can be calculated and can have infinite number of values in a range. Fair, price of objects, weight, IQ level, GPA, and so on. These are some of the examples of continuous data type. And in this screenshot at the bottom, you can see this is a data set for the famous Titanic data, I think, yes. And over here you can see the fair column. This fair column is an example of a continuous numerical feature. And similarly, if we talk about discrete data is a data that has values that can be counted and cannot be subdivided meaningfully. Number of children, number of visits to a doctor, number of students in a class, world population, and so on. These are some of the examples of discrete data type. And once again, in this screenshot of Titanic dataset, this sibling spouse column, parent-child count, and this ticket number, they are examples of discrete numerical features. Let us now talk about the categorical or qualitative data type, which is also classified into two types. One is nominal and the other is ordinal. Well, this nominal data has values that can be slotted into mutually exclusive categories that do not have any specific order. This blood group, gender, the color or make of a car, a list of country or cities, they all are examples of nominal data types. And once again, in this Titanic data set, this embarked column having three values, you can see only one over here. This S stands for Southampton. You can also see Cherbourg and Queenstown represented by C and Q under this column. If you see the entire data set, these are the examples of nominal features. And similarly, this home or destination column is also a nominal feature. Well, let's talk about ordinal data now, which has values that can be slotted into mutually exclusive categories that can be ordered or ranked, unlike nominal, which are of course unordered. Student letter grades, PSL cricket team ranking, maybe education level like primary, secondary, undergrad, income like low income, medium income, and high income, and so on. These are the examples of ordinal data type. And in this, once again, screenshot of Titanic dataset, this we have the example like over here, this P class, this passenger class, this column having three values, first, second, and third. You can see only the first class over here. This is an example of ordinal feature. Well, my dear students, after having a fair idea about the two main types of this categorical feature, that is nominal and ordinal, let us now see what is encoding of categorical features. Why we need to do this encoding and how to do this encoding. Okay. So let me answer the first question, and that is the what part. What is encoding of categorical data? Well, my dear friends, encoding categorical data is a process of converting it into numerical values so that the data could be fed to a machine learning model. Actually, most machine learning algorithms cannot handle categorical variables unless we convert them to the numerical values. Moreover, the performance of machine learning models also vary depending on how we encode the categorical variables. I think I have answered the what part and the why part as well. Now let me give you a bird's eye view of the techniques that one can use to encode categorical data. Scikit-learns, Pandas, and NumPy all comes with various utilities for transforming data into categorical types. This can be as simple as using a dictionary of categories and their corresponding integer values and passing it to the map method. So you can do it at your own. But right now we will be using Panda's getDummies method, for example, which is used for creating dummy variables using which each category is represented as a one hot vector. I think we have seen this in our Panda session. The main concern of today's session will be about the pre-processing module of sklearn. And we will inshallah discuss three encoder classes in detail that are most commonly used to transform columns of our dataset having categorical data. That is ordinal encoder, label encoder, and one hot encoder. This ordinal encoder class is used to transform input features of ordinal data type, while this label encoder class is used to transform output label. And soon we will see these practically in more detail. My dear students, in order to encode nominal data, that is data columns whose categorical values do not have any intrinsic order, we use a one hot encoder that represent or transform one column to multiple dummy variables. And inshallah, of course, we will see as how the column transformer of sklearn help us to apply all these transformations on different columns of our dataset in a single line of code. And finally, my dear students, after covering this video session, I strongly recommend you to explore this category, category underscore encoders. This is a library which offers a bundle of encoding techniques, some of which are shown over here. You may have to install it using pip if this is not already installed on your system. And I think there are roughly 15 to 20 different techniques for encoding categorical variables. The new are hashing encoder, Helmut encoder, frequency encoder, mean encoder, and there are many more. And all these encoders are fully compatible with sklearn transformers, so they can be used in your existing pipelines. For details, you can click this link and read that page. And I think enough of theoretical discussion on the how part of the question. And now let's move ahead and do it practically. Okay, so in this code cell, I'm loading the data from this disease.csv file in our data frame using Panda's read CSV method. And then I'm using this sample method of data frame that will return a random sample of just 5 values. I have used this random state argument for reproducibility. If you don't mention this second argument, every time it is called, it will return a random sample of rows, 5 rows. So let me execute it. Great. So this dataset has 1, 2, 3, 4, and 5. 5 input features and one output label column, that is disease. Based on these 5 input features, this is predicted. So this seems to be a classification problem. My dear students, I have just created this dataset for understanding the working of different techniques to encode categorical data. So there might not exist a true relationship between the input features and output column. Anyway, let's check out the shape of this dataset. So there are 100 rows or observations in this dataset, and of course 6 columns. And let me also check out the distinct values under each column using n unique method. Okay, great. So the gender and the city column are of course nominal variables having no intrinsic order and 2 and 4 unique values respectively. The gender column can take 2 values male and female, and the city column can take 4 distinct cities, and there are I think Sheikhupura, Islamabad and Lahore. Sheikhupura, Islamabad and Lahore, and the 4th city I think that is Karachi, that is not visible in this dataset right now. Well, this BP or blood pressure and this cough These two columns are ordinal variables as they are having values that can be ranked or ordered. This BP column can take, as shown over here, 3 values, and these values are low and normal, which are visible in this snapshot of the dataset, and the third one is high. While this cough column over here can have 3 values again: mild, moderate, and strong. And finally, this output column disease, it has just 2 unique values, yes and no. Okay, so let me also check out for the missing values using the info method of the data frame, df.info. Great. So it's just the age column, which is of float 64 type, that has 13 missing values. And remember, this gender, city, blood pressure, cough, they don't have any missing values. And if there are, we need to impute them before doing the encoding, of course. Moreover, do note that Panda's data frame shows all the categorical variables as having an object data type. Okay, finally, let's check out the count of different values under each column. And for that, let me check out under the city column, df.city dot value counts. So this is the method. So it tells us that under the city column we have 32 observations for the Lahore city, 30 for Sheikhupura, 22 for Islamabad, and 16 for Karachi. And similarly we can check out for others as well. Let me check out for blood pressure column, 47 for nominal, 28 for low, 25 for high, and let me check out for cough as well. I hope this makes sense. And I think now we have a fair idea about our data set. So let's move ahead and encode the categorical variables. My dear students, a label encoding is a popular encoding technique for handling ordinal variables, which assign each category value an integer starting from 0 to n-1. It is also termed as integer encoding. In scikit-learn, there are 2 classes that deals with this integer encoding. One is this label encoder, and the other is ordinal encoder. Well, this label encoder is used for encoding output or target variable, while this ordinal encoder is used for encoding input feature variables of ordinal type, that is having intrinsic order. This label encoder can encode one column at a time, while this ordinal encoder can encode multiple columns in one go. And finally, both encoders sort the values of a column alphabetically and then assign them the values. For example, in case of this city column, this Islamabad will be assigned an integer value of 0. And after that we have Karachi, I think over here, which is not visible, that will be assigned a value of 1, and so on. So it will be sorted alphabetically and then will be assigned numerical values. However, in case of ordinal encoder, we can mention what integer values should be assigned to each specific category. So these are the some of the differences that you need to keep in mind while you are using this label encoder or ordinal encoder. Let us practically understand all these concepts. And before that, do make time to click these 2 links and read sklearn documentation page of these 2 transformer classes. Well, let us first apply label encoder on the disease column, which is the target or the output label. Let's check out the head of the dataset this time. So this is the disease column, the output column, and we need to apply this label encoder on this column. And let us get the output column in our variable y, which I have done over here. I have used the ilock method. The column before this comma is the first argument, which means all the rows, while this -1 is the second argument, which means only the last column. Let me execute it. So you see, we have got a series object in y now, having just two unique values or classes, that is yes or no. And now let me just import the label encoder from the pre-processing module of sklearn. First we need to just create the instance of label encoder as let's suppose I have given it a name LE. Then we call the fit method by passing it the column which we want to transform. Let me execute it. So we have got the instance, and this is a trained instance because we have already called fit method on it. And after fit we need to call transform method, which returns an array of encoded values. And if you just want to check out what all classes are there, you can check out the classes underscore attribute. So this is the array if you want to see the array. So this is an array which has encoded the disease column having yes and no, and you can see that the first value is yes, the second value is no. So the yes has been encoded as 1 and the no has been encoded as 0, because that makes sense. Okay, so let me check out the shape as well. Of course, the shape of this array is 100. So there are 100 values, 100 observations in our data set. So we have successfully done with the encoding of the target label using the label encoder. Once again, remember, label encoder is only used to encode the target label. Let's move ahead and see the ordinal encoder. And we apply the ordinal encoder on the two ordinal input features in our dataset, and they are blood pressure and cough. Let me show you the head again. So this is the blood pressure column and this is the cough column. They are ordinal, so we are going to apply the ordinal encoder. And let me first apply it to the cough column. I have used the ilock method, getting all the rows and getting the two columns, that is column number 3 and 4. 5 is not inclusive. 0, 1, 2, 3 and 4, BP and cough. So we have got this data frame over here in this another data frame, that is x underscore BP underscore cough. Now we need to apply this ordinal encoder on these two columns at a time. The scheme is same as we have been following since our last session. We have imported ordinal encoder from the pre-processing module of sklearn. We have created the instance of the ordinal encoder, that is OE. So you see we have created the ordinal encoder. Now then we call the fit method on this. So this is once again very simple. So this is trained now, and if you check out the categories, you can check out the categories as well, categories attribute. So they are high, low and medium. Remember this categories attribute, over here we have the classes attribute in case of label encoder, while in case of ordinal encoder we have this categories underscore attribute. And note that the blood pressure column, the categories are high, low and normal, and they are of course sorted alphabetically, H and then L and then N, and they will be assigned integer values from 0, 1 and 2. And similarly for the cough column, The categories are mild, moderate, and strong. Once again, they are sorted alphabetically, and they will be assigned integer values 0, 1, and 2 respectively. If you want to assign integer values of your choice to different categories, then you can use the categories argument as I have done over here. So you can use the categories argument to ordinal encoder while creating the instance of the ordinal encoder. Here I am passing two lists. The first list is for the blood pressure, and this second list which I have highlighted is for the cough. And similarly, you can also specify the data type as well. I have specified data type as np.int8 while the default is float 64, and of course it will occupy less memory. So I have uncommented this line. Let me execute it again. So this time the instance of ordinal encoder says that the categories are sequenced like this. You see low, normal, and high. And this time this low will be encoded as 0, normal with a value of 1, high with a value of 2. And similarly, the mild will be encoded with a value of 0, moderate with 1, and strong with 2. So let's check out the categories. It also gives us the same information. And now let us do the transformation. Let me call transform method on x underscore bp underscore cuff. So this will transform. The shape is of course 100 by 2, and this is the array that has been returned. Note that this column, this first column, is the encoding of course the first is bp, so blood pressure, and the second column is for cough. And if you see over here, under the blood pressure column, the first two values are low, so we have the first two values as 0, 0 in this column. And similarly for the cough, the first two values are moderate and mild. So moderate will be given a value of encoding of 1 and mild with a value of 0. So we will get a 1, 0 in the second column. So 1, 0 in the second column. My dear friends, please do make time and understand how this mapping has been done. And meanwhile, let me move ahead. Okay, so let's talk about now one hot encoding, which we use for encoding nominal variables. My dear students, one hot encoding is the process of creating dummy variables, and each category is represented as a one hot vector. Let me describe this with the help of a very basic diagram, that image that I have created for you. And consider this feature column named color, which is a nominal variable having three unique values: red, green, and pink. Instead of one nominal variable color, we create three dummy variables, one for each category: red, green, and pink. Note in this middle table, having three columns, each row or vector represents a color. Each color is represented by a three-dimensional vector of zeros with a single one in the position corresponding to the category. This red is represented by 1, 0, 0. This green is represented by 0, 1, 0. And this pink is represented by 0, 0, 1. Well, before we practically implement one hot encoding using Panda's get dummies method or sklearn's one hot encoder transformer, let me tell you a problem that is caused by one hot encoding. I think we have discussed this before as well, that the input features in a data set should not have any correlation with each other. Rather, they should be independent. But if you see in this middle table, you can observe a relationship among the three dummy variables. And that is, if you add the values of any of the 3D vectors, this 1 0 0, this 1 0 0, 0 1 0, 0 0 1, they all sum up to 1. And this is a multicollinearity and is handled by a technique known as a dummy variable trap. And in a dummy variable trap, what we do is we actually skip one of the columns. So instead of having 3 columns, we are having 2. So instead of having n columns, one hot encoding should create n minus 1 columns, and this will overcome the problem of multicollinearity. And this is what is shown in the right table. Excuse me. And over here we have just dropped the first column, that is the column red, and now you can see that you have just 2D vectors, two-dimensional vector to encode the 3 colors. Note the red color is now represented by a 0 0, the green is represented by 1 0, and the pink is represented by 0 1. Well, my dear friends, other than multicollinearity, one hot encoding also increases the dimensionality of a dataset. And suppose that we have a feature column which has, let's suppose, 100 unique values. So if there are 100 unique values in this column and you encode them using one hot encoding, you will get 99 columns instead of 1. And one solution of managing this curse of dimensionality is that you keep the most frequently used, say, just 10 categories as a separate column. And for all the less frequently used categories, you assign a single 11th category, say others. So this way you will have a total of 10 dummy columns instead of 99. Finally, unlike label encoding, one hot encoding can be used in both tree-based as well as no tree-based machine learning algorithm, and this we will talk about inshallah ta'ala in our later sessions. And I think I have given a reasonably fair theoretical knowledge about one hot encoding. Let us now practically implement it using Panda's getDummies method and scikit-learn's One Hot Encoder Transformer. Okay, so let us view our dataset once again. So this is our dataset. We have encoded the output target decrease using the label encoder, and this blood pressure and the cough features using the ordinal encoder. This gender column is of nominal data type, so let us encode it using Panda's getDummies method. So in this code cell over here, I'm just using once again the ilock method to get the gender column only. So this is the gender column now, I have it. And now let me use the getDummies method. To the getDummies method of Pandas, I am just passing it the column on which I want to apply this one hot encoder. The single column, this will be of course converted to 2 columns as shown over here. Remember, there are a total of 100 rows in our dataset. So instead of this one gender column having 100 rows, we have 2 columns, gender female and gender male. I hope this is making sense to you all. And as discussed, we need to drop one of the columns to handle the multicollinearity. And this of course can be done by passing an argument drop underscore first is equal to true. So let me uncomment this line and comment this line. And now once I execute it, you will see a single column. So instead of 2 columns for gender, we have just 1 column now. Great. Okay. So now over here, remember a value of 1 means male and a value of 0 means female. You can map this one hot encoding with this actual values of the column gender. Well, my dear students, if you want to encode multiple columns of a data frame using getDummies method in one go, you can pass the entire data frame. and then use the columns argument to the getDummies method, to which we pass the list of column names on which we want to apply the one hot encoding. I hope this makes sense. Great. You see, since we have just the two categories, one was gender and the other was city, two columns, gender and city. Under the gender column, we have two values. So gender column has been transformed to a single column, that is gender underscore male. This makes sense, of course. For the city column, of course, we have 4 unique values. So we should have 4 dummy variables. And by dropping one of the columns, we get 3 variables. That is city Karachi, city Lahore, and city Sheikhupura. And if all these values are 0, as in this case, that means this is Islamabad. 000 is encoding of Islamabad. I hope this is making sense. And now we have 100 rows and 8 columns. So gender city, of course, has been dropped. Actual column was dropped, and we have got this gender male. The actual city column is dropped, and instead of 4 dummy variables, we have 3 encoded columns. Great. Okay, so let us encode gender and city column now using sklearn's one hot encoder. And for that, once again, I have used the ilock method of the data frame to get a data frame again having just 2 columns, gender and city. This is just for understanding. Well, this cell is actually importing one hot encoder from preprocessing module of sklearn. We are just creating an instance of one hot encoder. Do check out the help page of one hot encoder for details. This drop is equal to first is going to drop the first column. This sparse is equal to false. This will return an array instead of sparse matrix. The default behavior is returning the sparse matrix. This d type is equal to np.int32. This specifies the type of the number. So once we are done with creating the instance, we call fit, and of course now we have the trained instance of one hot encoder. You can check out the categories. So for the gender column we have female and male, and for the city column we have Islamabad, Karachi, Lahore and Sheikhupura. Note they have been sorted once again. And then we call the transform method. And of course to the transform method we pass the 2 columns, x underscore gender underscore city, and this will returns the array of encoded values having a shape of 100,4. Let me check out that array. So this is the array. Great. Note the size of this is 100,4. Over here we have 100,2. So gender has been converted to 1 column, encoded to 1 column, and city has been encoded to 3 columns. So total of 3 plus 1, 4 columns, and we have 4 columns over here. The first, this value is representing the city, so gender. So 1 means of course male, and this second is for the city, and this 0, 1, 0, this 3-dimensional vector is representing the city Lahore. And of course if you see over here, Lahore 0, 1 and 2, so 2 is Lahore, so this is 2, binary of 2. Great. I hope this makes sense. Great. Let's move ahead. Okay, so my dear friends, while doing machine learning, it is always better to do a train test split first and then do the encoding, so that there is no data leakage. Therefore, it is always recommended that you call the fit transform method on the train data and then call the transform method only on the test data. That means on the test data you should not do the training. Okay, so let me once again load this CSV file in this data frame. So this is the head of the data frame. Okay, so we have 5 input features, and one output label. My dear students, we have seen the train test split before as well. We have covered this concept in video session 6.6, but let me quickly give you a recap of this. The main idea behind train test split is to split the available dataset into two parts, and one part is called the training dataset on which you will train your model, while the other part is called the test dataset using which you will later evaluate your trained model. So for a machine learning estimator or algorithm like linear regression, you fit on the training data and predict on the test data. Similarly, my dear students, for a transformer like label encoder, you fit on the training data and transform both the training as well as the test data. So let's do this practically. And first of all, let me get the data frame X having just 1, 2, 3, 4, 5 input features. So now remember, X is our data frame having just the input features, and this Y is a series having the output label that is disease. Note that both X and Y have 100 rows, and for each observation in X we have a corresponding output in Y. So for each input feature, male, Lahore, 60, low, moderate, we have an output that is a yes for a disease. I hope this is making sense. Okay, so this is the train test split method. This code cell actually imports the train test split method from the model selection module of sklearn, and this train test split method is passed X and Y. Then the fraction of the test size, which I normally keep 0.2, and the random state, which is for reproducibility, that is every time you make this call using this random state of 5, 4, the same shuffling will be performed before doing a split. And of course this method will return a 4-valued tuple: X train, X test, Y train and Y test. Let me show you the length of these. So as per the test size, you see the X train has 80 rows, the Y train also has 80 values, the X test has 20 rows, and the Y test also has 20 values. Great. Let me show you the head of the X train, and let me show you the head of the Y train. Note the indexing over here. So this has been shuffled, remember. And similarly, let me show you the head of the X test and the head of the Y test. Once again, note the indexing. So they are exactly mapped. That is, the indices of the X train exactly map the indexes of the Y train. Similarly, the indexes in the X test exactly match with the indices in the Y test. Now we have the train test split. Let us now apply the transformation. Let me apply one hot encoder on the gender and the city columns. We have already done it. So drop is equal to first, sparse is equal to false, and this is the data type. So this has created an instance of one hot encoder. This point is important to note. We are calling the fit method on the gender and city columns of X train. Then we call the transform method on the X train and X test separately. X train and X test separately. And we get, of course, two arrays: X train gender city and X test gender city. Let me execute this. I hope this makes sense. So for the X train gender city, we have the size of 80,4, of course, and X test gender city, we have got 20,4. Remember, for gender and city, we just have two columns. Gender has been transformed to one column and city has been transformed to 3 columns. So a total of 4 columns over here. So 1 column for gender and 3 columns for city. I hope this makes sense. Okay, so let us now apply ordinal encoder to the blood pressure and the cough columns. The same flow which we have seen before. We call the fit method on xtrain, and we call the transform method on both xtrain and xtest. Great. Okay, so finally, let me apply the label encoder as well on the target data column. That is the Y train. Remember, once again, I'm calling fit on Y train. I'm calling a transform on Y train as well as on Y test. And this is the Y test array. Great. Remember, instead of yes or no, the values are encoded to 1 and 0 respectively. Great. For completeness, my dear friends, let me apply a simple imputer as well on this. Let me show you what we have seen before as well. df dot info. And remember that age column was a numerical column having 13 missing values. And of course, we can check out the total count using the isNull method on this column of the data frame. And for that, we have seen in our previous session the simple imputer transformer. I'm just using that simple imputer on this data frame. And we have done this thing in detail in our previous session. First, we just create an instance of simple imputer and tell it that the missing values we want to impute are np.nan, and the strategy we want to use right now is mean, that is calculate the mean of that column, the existing values mean, and use that mean for all the nan values. And remember, once again, we call the fit method on the age column of xtrain, then we call transform on age column of xtrain and xtest, and we of course get two arrays again. One is xtrain age and the other is xtest age. And of course, this is the xtest age array having 20 values, and you can observe the two locations. One is this and the other is this. These were the two locations having the missing values, and these are now imputed to the mean of the training data age column. Okay. My dear students, once we are done with applying all the transformations to different columns of our dataset, we have got resulting encoded or transformed arrays. The last step is to combine all the resulting arrays. And in this particular example, we have three arrays which we need to combine. So we have xtrain gender city. So this is one array which we have got after transforming the gender and the city column. Xtrain BP cuff. These are once again two columns, and this is the xtrain age, and these are the sizes of these. Okay, fine. So now we need to combine them, and to combine them we use numpy concatenate method to concatenate the three arrays along axis is equal to 1. That is, we need to concatenate them side by side, and this first argument is a tuple having all the three arrays. I hope this makes sense. And once I concatenate them, note that the number of rows stays the same, that is 80, but the number of columns are 7 now. So we have this xtrain transformed. Let me check this out. Xtrain transformed. So this is the array. I'm sorry, this is not visible that much. I think we should see it using a data frame. Anyway, so we have transformed the input features, and now we need to combine the Do the same for the test dataset. X test gender, X test BP curve, X test age. So these are the three arrays. And once again, we are concatenating it. And so we have this 20 by 7 array. Great. So over here, I'm just converting them to Panda's data frame for better visualization. So this is the original and this is the transformed data frame. My dear friends, do make time to match this. This gender column has been transformed to a single column, that is gender. This city column has been transformed to three columns, three dummy columns, city 1, city 2, city 3. And this age column has been imputed with the mean values. You see this 59 is there as such. This index 31 has a NAN under the age column, which has the mean value, that is 41.9. This BP and this cuff column has also been encoded. You can see the low, normal and the high have been encoded with 0, 1 and 2. Great. I hope this makes sense. Great job done. Fine. And similarly, of course, we can convert for the X test transformed as well. You see, this was for the training data set having 80 rows, and this is for the test data having 20 rows. You can see the mapping. Good. Okay. So my dear students, as usual, at the end, let me show you as how we can use the column transformer class to apply different transformers to our dataset in a single line of code. Whatever we have done, that was for learning purpose, and whatever we are going to do now, this is what is the industry standard. This is what code you will normally see once you will see the code of your fellow developers doing all these transformation and imputations. Well, anyway, this we have done before as well, I think. Okay, in this code cell over here, let me just do this. Okay, in this code cell over here, you can see that I have created three transformers: one hot encoder, ordinal encoder, and simple imputer. This one hot encoder is used to encode the gender and the city column. This ordinal encoder is used to encode the blood pressure and the cough column, and this simple imputer for the missing values imputation under the age column. So I have just created the instances. I have not trained them yet. This is a single line of code that will do the job. That is the column transformer. And remember, if you don't want to create these instances OHE, OE and SI, you can just simply place this line of code over here. So this will just be done in one line. Just for better understanding, I have divided it into two parts. Anyway, so this is a column transformer, and for this, of course, you need to first import the column transformer from the compose module of sklearn, and this line is actually creating an instance of column transformer, and to its transformers argument, the first argument, we need to pass a list of three valued tuples. The first value of the tuple is the name of the transformation which you want to give any name, but they should be unique within this transformer class. The second value of the tuple is the transformer object. This is one hot encoder, OHE. You can write down just the code over here. And the third value of the tuple is the list of the column indices or names on which we want this transformation to be applied. So this is a list. You can pass the column names. You can pass the indices as well. So this is the first transformation, that is one hot encoder being applied on the gender and the city column. This is the second transformation, that is one ordinal encoder being applied on the blood pressure and the cough column. And this is a third transformation, that is a simple imputer applied on the age column. Excuse me. Well, the second argument, this remainder is equal to pass through. This specifies what needs to be done with the remaining columns. That is, if there is any other column other than gender, city, BP, and cuff, and age, what you need to do with that. By pass through, I just mean do nothing with that column, just return that column to this transformer. Okay, let me execute it. So we have the column transformer object that has been created with the name of transformer. And as usual, the next step is to call the fit and then the transform. And once again, remember, we need to call the fit method on xtrain, not on the entire data set to avoid data leakage. So we call fit method on xtrain, and then we call transform on both the xtrain as well as on the xtest. Let me execute this. Great. So we have got in one go we have transformed all the columns, and we don't have to combine them. We have got the arrays 80 by 7 for the train and 20 by 7 for the test. And for better visualization, once again, I'm just converting it to a data frame. So this is the data frame, and to this data frame, I'm just passing this xtrain underscore transformed 1, which is this. Great job done. Great. Okay, so I think we have done with whatever we wanted to do as far as the categorical and nominal variables encoding is concerned. So that is all for today's session. Hope this was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning and Allah Hafiz.